In today's lesson, we are going to be looking at the area of composite shapes. So this is going to be kind of a warm-up into a more typical lesson. But what we're going to do first is we're going to watch a small video. You can find it on YouTube. We'll play it quickly because it's not too long. But as you're watching it, I want you to think about what do you notice and what do you wonder? So in the video, we were looking at a gentleman cut his lawn, and we kind of fast forward to the end where the lawn had already been cut. So something you may have noticed was maybe that was what happened, right? We kind of skip ahead to when the lawn is fully cut. You may wonder how long did it take him to cut his lawn. You may wonder how big his lawn is. You may wonder maybe things about the lawnmower itself, maybe where he lives, things like that. As long as you kind of came up with some questions and you're just asking questions. That's the biggest thing about these types of warm-ups, right? Just what do you notice and what do you wonder? As long as you're coming up with questions, now that's fine. Now, if they're more applied to mathematics, that's great. That's probably a little bit more better, or what we're trying to kind of head towards. But if you just come up with any questions, that's fine as well. So if we were to look at the gentleman's lawn, Mr. Pierce, we would have a kind of layout or a blueprint of his lawn as such. So what would be the area and perimeter of his lawn? Well, perimeter is relatively straightforward, right? Perimeter, we can add up all the sides around. Right, so 39 plus 15 plus 16 plus 15 plus 8 plus 65.6 plus 34. We can go through, we can add up all of the side lengths. And we get a perimeter of 192.6 feet. So that's relatively easy, right? But what about the area? We don't have an area formula on our formula sheet for a shape that looks like this, right? Perimeter we don't really need to worry about because again, we're just adding the sides around it, adding the lengths. But area requires the space in the middle, or the space that it covers. So we need to look at this a little differently. What we could do though is we know what our basic shapes are. We have a formula sheet that has the basic shapes on them. Can we divide this shape up into those basic shapes? Well, we would probably draw a line across here and then we would have a long rectangle. We know what the dimensions are, right? 39 by 34. We could draw another line here, creating another rectangle, which would be 15 by 8. We do have a kind of trapezoid shaped figure here in between the two rectangles. Now you're right that we don't know quite what this measurement is, but if we know that this measurement, we'll use different colors, if this measurement here is 15 and this measurement here is 39, and we know the entire measurement, we could do 65.6 minus 39 minus 15 would give us 11.6. So now we do know what that measurement is. And now that we've broken it up into 3 shapes, which we do have formulas for because they are our basic shapes, we can find the area of the one shape plus the area of the second shape and the area of the third shape and add them all together. So by going through and doing that, we can see that here we've broken up our shapes. We have our different measurements. We have our area of the first one. Here we have our area of the second one. And we have the area of our third one here. And when we're done, we have to add them all together to find our total area. So again, we can take a shape that's not a familiar shape or not a basic shape and add it all together, or break it down into our basic shapes, find the area of those basic shapes, which we do have formulas for, and then add them all together, which we've done here. And we can see we have an area of 1,602.6 feet. Now, the next thing is we're given some new information. We're given that for this one strip of the yard or of the lawn, it takes 19.27 seconds. So we know the distance, or we know what we're covering. We know the width of our lawnmower. So I want you to try to determine how long it would take to cut the whole lawn. What would we have to do? Well, first we would probably want to figure out, what is this area? What is the area of this strip of yard? Because we do know how long it takes him to cut that strip. So if we know what area he's covering, we could use that to figure out how long it would take to cut the entire yard. Well, it is a rectangle, so area would equal length times width. So in this case, 39 is the length times the width, which is the lawnmower, so 1.5. Which we get is 58.5. So we know that that 58.5 feet squared, or mowing that area, would take 19.27 seconds. Well, now what we can do is we can try to break up our entire yard into groups of 59.5. In other words, we are going to divide. So our total area, if we remember, is 1602.6. So we're going to divide that by 58.5. And we get 27 point, round it to 4. So basically there are 27.4 sections of this length or area, and we know how long it would take him to cut that area, 19.27 seconds. So 19.27, multiply that by 27.4 times. So I'm going to be cutting that area of grass that many times. So it should take me then 527.9 seconds. And if we wanted to convert this to minutes, 527.9 divided by 60, and we get roughly 8.79 minutes. So based on our calculations, we've got that it would take 8.79 minutes to calculate, or to cut the entire lawn. Well, now that we have an answer, let's go and let's see what the actual value was. So we saw, kind of lost it there, that it took 10 minutes and 26 seconds and 21 milliseconds. So why is our answer so far off? Right, we're off by around maybe just under 2 minutes. Why are we off by so much? Well, again, we've calculated it correctly, so there are maybe other variables that we didn't take into consideration. One, we can see that there is a flagpole in the middle of one. We can see that there is a tree. We can't really see it, we can see the shadow. There is a tree here that he would probably have to go around as well. As well, we aren't taking into consideration the fact that he would have to stop at the end of each path and then turn around. If he was able to somehow magically teleport back to the other side and just continue as if he was just walking straight the entire time, it might take more, or we might be closer to the 8.79 minutes that we calculated. We might also consider that he may not be walking at the same pace every single time. Right? He may be speeding up, he may be slowing down. In our case, it's safe to assume that he's slowing down a bit as he gets further and further along, especially when he gets to some of the larger portions over here. Right? So even though we may not have gotten the right answer based on what actually happened, we still went through the correct process. So it's more the process that we're going through and what we're calculating or how we're calculating than perhaps our final answer. Because again, there are many different things that come into play that may affect our answer. So just a reminder about 2D composite shapes. So again, we were looking at composite shapes. By definition, a composite shape or a composite figure is made up of two or more simple shapes. So again, the lawn we just looked at is an example of a composite figure because it was made up of two rectangles and a trapezoid. So that was a composite figure. When we're calculating the area, we just have to break it down into those simple shapes and calculate the area of each. When we're dealing with perimeter, we're just adding up the distance around, so generally speaking, there's not too much that we have to do that's different. We may have to do some smaller calculations to maybe subtract or minus, similar to what we kind of had to do back up here to figure out these heights or these measurements. Similar to something like that, using our general reasoning. But again, it's not as complicated as, say, finding the area of a composite figure. So, one last example. So if you're working with someone, you can try this with them, or you can try this on your own. But what does it cost to paint this sign if paint costs 0.55 or 55 cents per meter squared? So again, we have two different shapes. We have a 4x4 shape, or sorry, a 4x3 shape rectangle, and then we have a semicircle. Well, for the rectangle, area, we'll say area 1, area 2. Area 1 is length times width, 4 times 3, or 12 meters squared. For the area of the semicircle, we have pi r squared, and because it's a semicircle, I'm going to divide this by 2 because I only want half the area of a full circle, right? If I did the other formula or just left it, it's a bad circle, but I would be finding that entire area, which I don't want. I'm only concerned about a semicircle, which is this portion. So pi, or 3.14, times r, and r is the radius, and the radius is equal to half the diameter. So in our case, the diameter is 4, the distance across is 4, the radius is equal to 2. So 3.14 times 2 squared, all divided by 2. And we should get 6.28 meters squared. So now my total area is going to be the two areas added together, 12 plus 6.28, which equals 18.28 meters squared. Now I know my total area, and I know now, or I also know that it costs 55 cents per meter squared. So if I have 18.28 meters squared, I'm going to multiply that by 0.55. And I'm going to get $10.05. So it's going to cost me $10.05 to paint this sign based off of the measurements and the cost of paint. So again, the main thing with the composite figures is that we're breaking it down into simple shapes. In the next lesson, we're going to go through more specific examples of actually calculating them, but this one was just more of a warm-up to get us introduced to that idea, as well as some kind of real-world application, even though you may not be calculating how long it would take you to mow the lawn. If you're ever curious and you have a composite figure shaped lawn, now you know what you'd have to do.